The United States government is engaged in an extended project to perfect vehicles for use in lunar exploration. Designs for a Lunar Scientific Survey Module, or LSSM, are fairly well advanced by NASA-contracted corporations, and work continues on refining their configurations. At the same time, the Geological Survey is conducting tests to define the exploration format, outlining the tools and techniques that will be used on the lunar surface. A vehicle was needed to simulate the LSSM during these field tests. A vehicle which would conform to many of the constraints of the proposed lunar modules, but which could operate in a variety of terrestrial landscapes. Furthermore, it should be constructed out of standard automobile parts so that repair and maintenance would be minimal problems in the shop or in the field. This vehicle will be used under a variety of test constraints. It must serve as more than simple transportation. In testing lunar exploration systems, a close simulation of the actual LSSM must be made. The Field Test Systems Unit at the Geological Survey's Center of Astrogeology in Flagstaff, Arizona, set to work. And the result was Explorer. In November 1966, R.A. Mills began the design of the vehicle based on the requirements of the Surface Planetary Exploration Branch. By February 1967, design was completed and approved, and the necessary components were assembled. Construction began with the assembly of the engine and gear train, all provided through government supply agencies. The frame, equipment housings, and steering control systems were then built and installed on the vehicle. By May, construction was complete, and Explorer was ready for field testing. While the Explorer is not at all meant to be a lunar prototype, the general configuration that is expected on the LSSM is here incorporated in a relatively inexpensive and easily repairable vehicle. It is 14 feet long, has a wheelbase of 120 inches, and ground clearance of 22 inches. Explorer is powered by an 8-cylinder engine with an automatic transmission. It is capable of 2 different gear ranges, but is always operated in low range during field tests. This power supply feeds a radio and other auxiliary equipment. Mounted underneath the rear chassis is a 2,500-watt generator, which furnishes 115 volts AC to the power supply, where it is converted to direct current, variable from 0 to 36 volts. The control panel next to the driver contains a speedometer and various indicators. All the control wires terminate in a 24-pin quick disconnect plug so that the entire unit may be removed for repair or modification. The test subject, simulating an astronaut, sits at one end of the vehicle. Once he is seated, the step is raised by electric motors and becomes a footrest. The footrest and control configuration were designed to allow for the constraints of a suited test subject. Steering, engine throttle, and braking controls are combined in one drive control. Moving it forward opens the throttle, backward operates the brake. Both these controls are connected by mechanical cable. Lateral movement of the control stick activates electrical relays which start the steering drive motors and turn the wheels. The transmission control is to the driver's left and is easily operated from the sitting position. It has 3 speeds forward and 1 reverse. Explorer has several advantages over vehicles previously used in lunar exploration testing. It is constructed from standard automobile parts, which allows easy repair of moving parts. It also surpasses previous vehicles in mobility in a variety of terrains. Under suited constraints, a test subject will not be able to see behind the vehicle, and a backing up operation might approach the impossible. On such occasions, he will be able to move to a rear control seat, which will be installed soon. Only the drive and transmission controls will be duplicated there. This second drive control will be connected in parallel with the main control at the front. Once the vehicle is in a maneuverable position, the test subject would return to the front control seat. Another proposed addition is a remote control connected either by cable or radio link. Such a control could be used when the operator considers riding the vehicle in steep terrain would not be safe. An alternate method of steering is available by inserting a steering wheel into a socket in front of the driver. The limits of Explorer's mobility are tested on rough lava flows near Flagstaff. The surface here is uneven and irregular, composed of sharp, jagged lava blocks. Current analysis of lunar photographs suggests that portions of the moon's surface may have these same characteristics. Explorer has proved itself as a valuable lunar exploration testing vehicle. It is relatively inexpensive, it is easy to repair, and its operation is easily learned. After a 5-minute checkout, a driver can take the controls himself. In 1/2 hour, he can perform most maneuvers, and at the end of 1 hour, he is fully competent at controlling the vehicle. The use of the Explorer in lunar testing programs by the Geological Survey will allow more exacting simulations of lunar exploration. And these tests will lead to the definition of an exploration format designed to return the maximum useful information in the shortest possible time.